Hi everyone, I'm Dr. Saranya. Here I'm going to present computer networks and I'm Associate Professor from the Department of Computer Science and Engineering. I said so. The topic that we are going to discuss here is about wired LANs, that is also called as Ethernets. So there are two different layers in this Ethernet. So how it is being divided is that LLC and MAC layers. So LLC is nothing but logical link control, which will have flow control, error control, and part of framing, whereas medium access control is only for framing. So here we can able to see the logical standard representation produced by IEEE for LAN, so which will have logical link control and medium access control. So in the transmission medium, it takes physical layer, data link layer, and upper layers above that. And in the IEEE transmission standard, it just holds up with the Ethernet, then token rings and token buses. So these are the extra added ups that is happening in the IEEE standard when compared with the normal OSI or an internet model. So the standard Ethernet, which was created in 1976 at Xerox Palo Alto Research Center, and it was being gone through for 4 generations, and now we just use that as Ethernet here. So under the revolution, it has different speed up techniques into it, and standard Ethernet is minimum of 10 Mbps, whereas fast Ethernet is for 100 Mbps, and gigabit Ethernet is for 1 Gbps, and 10 gigabits Ethernet is for 10 Gbps. So max up layer is nothing but it will be a combination of set of frames, preamble, standard frame delimiter, DA, SA, data, and CRC. So if you take a preamble, it will be of 7-bit of len size and which will have a timing added up with the physical layer and not connected with the frame. Whereas a start frame delimiter, which will be holding up 2 bits, is 1 1. It alerts the next in the destination address. Whereas DA, that is the destination address, which will be of 6 bytes, whereas source address will be of 6 bytes. So the data will be minimum of 46 to 1500 bytes, and CRC will be the last field in the error reduction method. So CRC will be holding up 4 bits here. So this is a MAC framework, which is 802.3 MAC framework. So preamble, which is holding up 56 bits for alternating ones and zeros, and whereas the start frame delimiter, which is a flag which is having 1 bit for it, and a destination address, source address, length of what type of data is being transmitted, and CRC. So the minimum and the maximum lengths are being discussed in this framework. The minimum frame length will be of 512 bits to 64 bytes, whereas the maximum frame length will be 12,144 bits to 1,518 bytes. So the frame length here during the data transmission will be of 64 bytes to the minimum and maximum of 1,518 bytes to the maximum. So if you take an Ethernet address in a hexadecimal notation, it will be in this format. So here you can able to see the hexadecimal address, which is holding up 48 bits into it and 12 hexadecimal digits into it, which is of 6 bytes. So each unicast and multicast addresses are being denoted. So unicast means it will hold on with 0 and a single byte of data will be present, whereas multicast means it will be holding up with multiple set of data. So the least significant bit for the first byte defines the type of address, and if the bit is 0, the address is unicast, and otherwise it is a multicast. So bit is 0, it is unicast. Understand that? And the part from 0, it is 1, it will be a multicast. So the broadcast destination address is the special case of the multicast address, and which all the bits are ones. So here you can see the categories of standard Ethernet. So some of the common implementations can be of 10 base 5, 10 base 2, 10 base T, and 10 base F. So this 10 base 5 is used in bus and thick coaxial cables, and it uses the bus topology, whereas 10 base 2 also uses the bus topology and thin coaxial cables, and whereas here this 10 base T, it uses star, and which will be using a UTP, and whereas user datagram transmission protocol, whereas F is for filtering and which is using a star. Okay. So bus and star topologies are used mainly in the standard Ethernet implementation, and here they have twisted pair of fibers where the two stations of Manchester encoder and the decoders are present with 10 Mbps standard. So this is how the implementation is being done, and network interface card will be present in 10 base 2, whereas in the 10 base 5 a transceiver will be present, which will be receiving and transmitting the data without and detecting the collisions that whatever is happening around. So 10 base 5 implementation, it is fully of baseband with the digital of minimum 10 Mbps, maximum 10 Mbps and 500 meters of cable length, which will able to transmit the data to the thick cable coaxial cables. Whereas 10 base 2, if you see, the cables will be of thin coaxial cables, and the maximum of 195 meters it can able to cover with 10 Mbps speed. Whereas if you take 10 base T implementation, which will be a T hub, two pair of UTP cables will be present, which will be a twisted pair cable and with 10 Mbps speed. Whereas fiber optic cable is used in 10 base F implementation, will be holding up with 10 Mbps and the baseband. So here comes the end of this topic, that is wired LANs. So there are different forms of wired LANs that are present, and which is using coaxial cable, fiber optic cables and UTPs for data communication and interconnection between sender and the receiver during the data transmission. And the data transmission can be of multicast or Unicast method. If it is unicast, it will be represented as 0, whereas if it is a multicast, it will be in the form of 1. So thanks for watching this video.